Logical connective also include and a conjunction that joins two or more propositions that are true at the same time. Second one is or, a disjunction that is true when either A or B is true. Not, a negation that is false when A is true. If, then, a condition that is true when A is true and B is true. If and only if, a bicondition that is true when A is true and B is true, or when B is true and A is true. Moving on to the example question number 1. Let P and Q be the proposition. P, it is raining. Q, the ground is wet. Write this proposition using P and Q and logical connective. A, it is raining and the ground is wet. The answer is P and Q. B, it is raining but the ground is not wet. Answer P and not Q. C, it is not raining and the ground is not wet. The answer not P and not Q. D, if it is raining then the ground is wet. Answer P implies Q. E, it is either raining or the ground is wet, but it is not raining if the ground is wet. The answer is P or Q, and P implies next question. Construct a truth table of this compound proposition. A, P or Q implies to P and Q. For the column P, the first two row is true and the rest is false. For the column Q, first row is true and the second row is false, and follow the sequence until row 4. For the third row, P or Q, the first three row is true and the last row is false. Fourth column is P and Q. First row is true while the last three row is false. For the last column, P or Q implies to P and Q. For the first row, true, we get true. For the last row, false, also we get true. For the second and third row, we get true, false, we get false. P biconditional Q or not P biconditional Q. For the column P, the first two row is true and the last two row is false. For the column Q, first row is true, second row is false, same sequence as the third and fourth row. For the column not P, the first two row is false while the last two row is true. For the fourth column, the P biconditional to Q is true whenever the truth value of P and Q are same. For the fifth column is also the same as fourth column, which is not P biconditional to Q is true whenever the truth value of not P and Q are same. For the last column, P biconditional to Q or not P biconditional to Q is true whenever either fourth or fifth column are true.
Assalamualaikum and hi. So next I will explain about the converse, contrapositive and inverse. For the implication, so this is in the form of if P then Q. In symbol, we have P implies Q. Next, we have converse statement. So this is in the form of if Q then P. In symbol, Q implies P. The third statement is the inverse. So this is in the form of if negation P then negation Q. In symbol, in negation P implies negation Q. The last statement is contrapositive in the form of if negation Q then negation P, or in symbol negation Q implies negation. So for example 1, if the light is on then the room is not dark. So the P is the light is on and the Q is the room is not dark. So for converse, Q implies P. If the room is not dark, then the light is on. Contrapositive, negation Q implies negation P. If the room is dark, then the light is not on. Inverse, negation P implies negation Q. So if the light is not on, then the room is dark. Next, for example 2, if she study hard, then she passed the exam. So the P is she study hard and the Q is she passed the exam. So for converse, Q implies P. If she passed the exam, then she studies hard. And for contrapositive, negation Q implies negation P. So if she does not pass the exam, then she does not study hard. And for inverse, negation P implies negation Q. If she does not study hard, then she does not pass. So for example 3, you will graduate only if you pass the exam, which is you will graduate is the P and you pass the exam is Q. So for converse, if Q then P, if you pass the exam, then you will graduate. And for contrapositive, if negation Q, then negation P. If you do not pass the exam, then you will not graduate. And for inverse, if negation P, then negation Q. If you do not graduate, then you are not past the exam.
Okay, now we move to the example question. So first question is simplify by using law of logic for negation. Inside the parentheses we have P or negation P and Q. So first we can apply the De Morgan's law. So it will become negation P and negation P and Q. So we can apply De Morgan's law again, and we can use double negation law since we see there is two negation symbol. So it becomes negation P and negation P and P or negation Q. So now we can see there is two different symbol, so we can apply distributive law. We cannot use absorption law because of the P is not the same as negation P. So we apply distributive law. It becomes negation P and P or negation P and negation Q. Next, there is negation P and P, so we can apply inverse law and it will become false. It's in contradiction. Or negation P and negation Q. And we can apply identity law since there is false and symbol or, so we can use identity law. It will become negation P and negation Q. So lastly, we can simplify it using De Morgan's law. So it will become negation P or Q. Question 2. Simplify the following expression: P by conditional Q and P implies Q or Q. So first, there is biconditional symbol, so we can apply the definition of biconditional. So it becomes P implies Q and Q implies P, and P implies Q or Q. So next, I want to change the order, so I am using commutative law. So it becomes Q implies P and P implies Q, and P implies Q or Q. So since I see there is the same statement, which is P implies Q, there's two P implies Q, so I want to associate the parentheses. So I'm using the associative law, so it becomes Q implies P and P implies Q and P implies Q or Q. It's just the same, just change the parentheses order. So next, we can see that there is a different symbol and we have the same statement, which is P implies Q, so we can use absorption law. So it will only remains P implies Q, so it becomes Q implies P and P implies Q. So since this is we can use definition of biconditional, so we just written as P by conditional. Last question is by using law of logic, show that negation P or P and Q and R logically implies with P or R. So first, I apply the definition of implication, so it will become negation P or P and Q and R or P or R. So next, I apply the De Morgan's law and also double negation law since there is a double negation symbol. So it becomes P or P and Q and R or negation R or P or R. So since I could see there's two same statement, which is P and the symbol is different, so I can apply the absorption law. So it becomes P or negation R or P or R. So next, I will use associative law. So I associate the parentheses. So it becomes P or R negation R
or P or R. So next, I can use the idempotent law because of the P or R. So I can just terminate one P. So it becomes P or negation R or R only. So next, I associate again the parentheses with negation R and R. So the form, it will become P or negation R or R. So we can use inverse law because of the negation R or R. So it will become true. So the last one, we can apply domination law because we could say P or true, so it becomes true. Therefore, we could say that negation P or P and Q and R is logically implies with P or R because it shows true.
So I will explain the first question. The question is, given the following argument, if Alex plays football, he will get hurt. If Alex does not play football, he will study. If Alex is studying, then his parent will be proud. The task one is declare the primitive propositions using symbols P, Q, R, and S. The second one is write the premises of the argument using those symbols. The third one is prove the validity of the argument using the rules of inference. So for the solution, we declare the premises using P, Q, R, and S. P is Alex plays football. Q is Alex is injured. R is Alex is studying. S is his parent will be proud. So the premises is, the first one is P implies Q. The second one is negation P implies R. The third one is the third one is R implies S, and we get the conclusion is negation Q implies S. So to solve this, we can use rules of inference. So the first step, we use law of syllogism for premise 2 and 3. So we get the next step, which is negation P implies S. So for the fifth one is we use contrapositive method. We negate and switch the first premises. So we get negation Q implies negation P. So for the last one, we get negation Q implies S by using law of syllogism by premise 4 and 5. So the conclusion, so we get that the argument is valid. So I will explain the second question. Given the following argument, if Sarah studies hard, then she will pass her exams. If Sarah passes her exams, she will get a scholarship. Sarah will either fail her exams or not get the scholarship. Sarah does not fail her exams, therefore Sarah does not study hard. So the tasks are the same as the question 1. So we will move on to the task 1. We all know that P is Sarah studies hard. Q is Sarah passes her exams. R is Sarah gets a scholarship. S is Sarah fail her exams. So for the task 2, the premise is 4. The first one is P implies Q. The second one is Q implies negation R. The third one is S or negation R, and the fourth one is negation S. And the conclusion is negation P. So for the step 1, we need to use rule of disjunctive syllogism with premise 3 and 4. So we get that negation R. So the second step is we use contrapositive method. We get that negation R implies negation Q. So for the sevens is we use modus ponens by premise 5 and premise 6. We get negation Q. And the eighth one is negation Q implies negation P by using contrapositive method using premise 1. And the last one is negation P, which is same as the conclusion by using modus ponens using premise 7 and premise 8. So we get the conclusion, which is the argument is valid. For the last question, given the following argument, if Amin is wealthy, then he is busy. If Amin is busy, then his cat will be unhappy. Amin buys cat's food, or his cat will be happy. Amin does not buy cat's food, or he will adopt another cat. Amin does not adopt another cat, therefore he is not wealthy. So the tasks also are same as question 1 and question 2. So we'll move on to the task 1. We will declare these primitive propositions using symbols. P is Amin is wealthy, Q is Amin is busy, R is Amin's cat will be happy, S is Amin buys cat's food, T is Amin adopt another cat. So for the task 2 is premises. We know that this question have 5 premises and 1 conclusion. So the first premise is P implies Q. The second one is Q implies negation R. The third one is S or R. Fourth one is negation S and or T. The fifth one is negation T. So the conclusion is negation P. Okay, for the first step, we use law of syllogism using premise 1 and premise 2. So we get that P implies negation R. So the second one is we use commutative law by change the symbols. So we get that R or S. So the third step is we use equivalence identity. So we get the negation R implies S. So for the fourth step is we use law of syllogism. We get P imply S by 6 and 8 premises. So for the next, we use equivalence identity also. So we get the S implies T by using fourth premise. And the 11th one is P implies T. We use law of syllogism using 9th and 10th premises. So for the last one, we get the conclusion as negation P by using modus tollens, using premise 5 and premise 11. So we all conclude that the argument is valid.
For the question 1, the question asks if S and T are two sets defined by S, real number is x squared minus 11x plus 24 less than or equal to 0, and T, real number is 3 less than or equal to x and less than or equal to 8. To answer this question, we have to do analysis of proof. For A, we just need to rewrite hypothesis from the question, while B, we have to rewrite the conclusion from the question. Next, we have to make B1 that we take from B, which is universal quantifier real number x element to S and x element to T. After that, we have to write the relate of A at A1. So we choose A element S, while B2 from B1 we can get A element T. A2 that we already declared before at A2, which is A element S, so we have to replace the A from X at T. There we will get A3 for we solve A through simplify the A2. From there, we can make table to search which value is negative because of the question is less than or equal, and at each column we have to put the interval at the real number line, and we will get the value of AC, the negative sign from the table, which is 3 less than or equal to A and less than or equal to 8. Last but not least, at A7 we will conclude as A element to T, which is same with B2, and it is as if T are the two sets defined by S real number x is x squared minus 4x minus 12 more than or equal to 0. T real number of x is x less than or equal to negative 2 union x more than or equal to 6, then SC subset to T. Analysis of proof of this question, as usual, we have to declare A and B. Then we have to make B1 that relate with B, which is universal quantifier real number, S element S and X element T. After that, we can search for A1 that we get from A, which is we have to choose A element to S, so we can get B2 A element to T. After A2, which we make A1 A element to S, so we have to take from S and replace X in terms of A. A3, we simplify A2. A4, we have to separate each equation from the simplification and make more than or equal and less than or equal. So from this, we have to make number line and shape where the amount should place, and there we will get the answer as the picture. The answer should write as A5. Lastly, we can conclude as A element T, and it's same with B2, so it is proven. Proof that if fx x squared plus 1 and gx 3x plus 1, then g more than or equal to f on set S. X element to real number which is 0 less than or equal to x less than or equal to 3. Analysis of proof of this question is we have to declare A and B, then B1 universal quantifier S element S and Gx more than or equal to Fx. For A1, we choose A element to S because of we want to make S in terms of A. At B2, we should conclude GA more than or equal to FA because of we make S in terms of A at S. So in A2 is 0 less than or equal to 3. A3, we have to separate each value and we will get in one term which is A squared minus 3A less than or equal to 0. B3, we have to put the value of Gx and Fx and solve the equation, and the final solving we make as B4, which is same with A3, so it is proven.